So let's start off by talking about the use cases for energy storage systems. And really we've outlined two main use cases, and one that we're seeing a lot at Mayfield Renewables is resiliency. And so we are getting customers where outages are becoming more and more common, whether it be for natural disaster type events, fires, storms, things like that are taking the grid out. And there's also situations where we are getting a lot of customers where the utility is proactively shutting the grid down particularly when there's fire hazard, when there's high wind events, and they being the utility are concerned with transmission lines, distribution lines coming down and potentially starting fires. And so they are doing these public safety power shutdowns, as they call them, PSPS. And so that's a big part of what we're seeing as well. Those are becoming more and more common. And so one of the big use cases is doing this resiliency. So having the ability to keep local loads, or whatever you have on site, be able to keep them powered up during a grid outage. Kind of doesn't matter what that grid outage is. And show you some graphs around that, and we'll talk more about that in the microgrid stuff, about how to determine those loads and modeling for those loads and those kinds of things. But that's a big use case. So in this case, I'm showing a DC coupled system that has the ability to back up some loads. And so you can see this looks pretty similar to what we were looking at just a minute ago. We have the solar up there at the top going to some sort of battery management system. Think of that as your charge controller, going into the energy storage system. That energy storage system and the battery management system feed, again, another multi-mode inverter. We happen to have typically transformers in for these larger systems, and then we are connecting to our utility. And so in this case, we are connecting through an aggregation panel to back up some loads. We have an isolation device there that will externally isolate the utility from our system that we're trying to back up. So we'll talk about that in terms of components later on as well, kind of the importance of that device in of itself. But in this case, it's an external device. In those other systems I showed you earlier, it was internal. So that's just something to keep in mind. So we have a DC coupled system here, just at a larger scale. The grid forming inverters, on the other hand, are, I would say, you're going to have to, when you're doing a resilient system, if you're doing something with backup, your inverter has to be able to provide a sine wave, has to be grid forming. So it has to be able to provide that output that the loads can run off of. And if you have those inverters, those PV inverters that are grid following, that you're AC coupling, that battery inverter has to be able to form that grid to allow the inverters to connect to it. Typically what you are going to have to do is, on some level, be doing some sort of creating a load profile. Ideally you would have 15-minute interval data. Sometimes you can get that from smart meters and from the utilities, not always possible. So, creating some sort of a load data, or a load table, and that's what we're looking at that bottom image there. So we have some data there in the background, and then we are creating these load tables based on the size of the system, the actual use of the building, hopefully, preferably with actual data that you've gotten from, again, those smart meters, or that you've actually collected yourself. You could put in meters, and that's something that we like to do when we can, but it's not always possible. And so being able to see what the loads look like. And so you can see in this image, there's a couple months there that are dramatically different than the rest of the year in terms of what that load, the actual values. The profile looks very similar, but there's a big difference there in between the power requirements between the different months. So understanding that and putting that into the model properly is really, really important.